Hi, welcome back. Today we are gonna solve Leetcode problem number 2798. The problem states that largest element in an array after merge operation. So going by the description, you are given an array zero indexed array nums consisting of positive integers. You can do the following operation on the array any number of times. Choose an index I such that 0 is less than equal to I is less than nums dot length minus 1 and nums of I is less than equal to nums of I plus 1. Replace the element nums of I plus 1 with nums of I plus nums of I plus 1 and delete the element nums of I from the array. Return the value of the largest element that you can possibly obtain in the final array. So yeah, let's go through the example ones to understand it very clearly. So we can apply the following operation on the array. Choose index I. The resulting index will be 5, 7, 9, 3. Choose an index I equal to 1. The resulting array will be 5, 16, 3. Choose an okay. So okay, they did this thing first and got 5. Then they did 5. Then they did 7, 9, and then they got 16, and then they were left with 3, so 21 comma 3, the largest element in the final array. It can be shown that we cannot obtain a larger element. So yeah, that's pretty much this question. So uh, one way to look into this, I think, is like we can have 7 comma 9, and that okay, we can have 2 comma 3. 2 comma 3 will become 5. Then we can have 7 comma 9, which will become 16. 16. uh, and then we can have 16 comma 3, which will become 19, and 19 plus 5 will give me the resulting value. So why we did not went with that one, I'm not pretty sure. Like, okay, let's try to understand it again. I such that I is less than nums dot length, nums of I is less than equal to nums of I plus 1. Replace the element nums of I plus 1 with nums of I plus nums of I plus 1 and delete the element nums of I from the array. So return the largest element that you can possibly obtain in the final array. I'm yet not sure like why we did not do 21 comma 3 here. Okay, it's clearly mentioned that nums of I plus 1 should be greater than equal to nums of I, then only this operation we can perform. Okay, that's the reason that we did not do this thing. So yeah, so so what if we would have done 9 comma 3, which would have got us 11, okay, and 3 comma 7, which would have got us oh, like okay, we cannot do 9 comma 3, right, because nums of this is not bigger. So we need to have a longest increasing subsequence basically. So this 2 comma 3 comma 7 comma 9 is the longest increasing subsequence, and from the left part we need to go on applying that summation part, or like we need to get the summation of the longest increasing array. That is the question, I think. So if you will see here, it is 3 comma 3, but okay, so okay, so one more observation in this question was like we don't need to start from the right, we need to start from the left and see like if the value is small, we need to add it and we need to compare it with the left part. So this is one more observation for me in this question. So and we need to go on like going till the value is smaller from left side, from the this side, whatever side this is, right side. Yeah, so let's start now. So let's note down the observation ones. Okay, thought process for this question, and let's first let down the observation. So I will be not writing the thought process, like we are not going to use any of the data structure here. So I think it will be simpler, simply iterating over the nums. So yeah, let's note down the observations. So we need to get we need to get decreasing decreasing subsequence decreasing subsequence. So we need to get like decreasing subsequence from the end of the array which has maximum sum. So this is what we basically need to find, and we will be just solving this one. Like we will be just, this is our main problem statement if this gets broken down. So yeah, let's start. Int n is equal to nums dot size int. Okay, we will have a long here. Long sum is equal to 0. Yeah, and then we will have for int I is equal to n minus 1, I is greater than equal to 0, and I minus equal to 1. Yeah, I minus equal to 1. Yeah. So if nums of I, if I is greater than okay, I should be okay, I is greater than 0. Okay, yeah, let's have I greater than 0. Yeah, if nums of I is bigger than nums of I minus 1, nums of I minus 1, then nums of I minus 1 will become nums of I plus nums of I minus 1. Okay, so yeah, I think we need to just do this thing, and let's try to iterate of array like after doing this operation. Let's return one more thing here is like this is int, so which will be causing a issue like when we are adding, but yeah, for not the time being, let's see if we are going in the right direction. Is less than I is less than n I plus plus cout nums of I. Okay. Yeah, I always mess up here. So yeah, we got the resulting value what we needed. So just we need to make sure that this is long and not nums. For that, what I need to do, I'm not pretty sure yet. So yeah, we can have like long sum is here. Okay. So mm, what is the constraint? It is 10 raised to power 5. So it does not matter actually like here if it is 10 raised to 5 or what. I'm just thinking like, is there any chance like I is always greater than, okay, I think, don't think that is the, okay, let's have some int mx, and I think it will fail. That's not the way to do it. Okay, so I don't know like how to make nums as long so that I can get the answer directly. Okay, we can have sum plus equal to nums of I minus 1 else sum. Okay, so we need to start from n minus 2 and I is greater than equal to 0. Then we will have sum plus equal to nums of I. We can have here I plus 1 and here plus sum is equal to nums of I. So sum is equal to nums of I, and we will have long mx sum is equal to int min, and mx sum will be equal to max of sum comma mx sum. Similarly, we will have it here. Okay, and then we will return mx sum. Let's try this out if it should work. I think. Okay, you messed up. So why did it fail? Let's try to understand. So what will happen is like sum will go here. Okay, first we will start with 3. Okay, so here sum will be 3. Okay, now 9 will come. 9 is greater than 3. Okay, I don't think this will work out here. uh, to go back. Okay, bool first time so what is happening, what is happening wrong here? Let's try to understand. Like what is happening here is like nums of I minus 1. I think this should work, right? Yeah, so mx sum is equal to int min, mx sum is equal to max of sum comma mx sum. Let's remove this one. Okay. So yeah, we got 31 here. I think we are missing something. So we are getting extra addition. So So what will happen here is like at the first time when it will come and it will check here 9 comma 7 it will get, and then we will be going, okay, this should work, and let's make first time false and else. Okay, let's set it as true. Okay, so here somehow we got answer as 0, so I don't know why. So okay, greater than equal to, I think, 6. Okay, then 6 will come. I think it did not compare that 6, here it came. See, I am aware that there is one simple solution, like creating a vector and like having all the long values into that. But since I wanted to play on the space complexity, I was not moving on that way. Looks like that is the only solution available. Although our thought process and everything is correct. So yeah, let's move in that direction now. Uh, vector of long, temp. Let's delete this thing. Now, since temp is equal to nums, let's, I think it will copy the value. Let's return 1. I think it will not. Okay. For int I is equal to 0, I is less than nums dot size I plus plus temp dot push back nums of I. Okay. Now I think this will work out. Now we will have the same equation what we wrote before. So we will have like for int I is equal to temp dot n minus 1, n minus 1 I is greater than 0, I is greater than 0, I minus minus, if temp of I is, so we need to start from uh, if temp of I is greater than temp of, so if temp of I is greater than temp of, wait, we need to see one thing. Control C, Control Z, let's not go back, I minus minus, so we'll have if temp of I is greater than temp of I plus 1, temp of I plus 1, so we will have temp of I is equal to temp of I plus temp of I plus 1. Okay, so what we are doing, we are checking if the I is equal to n minus 1, and if temp of I is greater than, okay, we will start from I at n minus 2. So since 9 is greater than 3, okay, we need to have decreasing order if temp of I is less than, so here we can have 7 comma 9. Okay, it is smaller, so temp of I will become 7 plus 9. Okay, we will have long sum, long sum is equal to 0. Now sum will be mx sum will be equal to max of mx sum comma temp of I. We will return mx sum. Okay, let's try to if it works out. Okay, we are not getting the correct answer again. Let's try to iterate over temp for int I is equal to 0. I is less than temp dot size I plus plus. I think it is because of this condition. Let's try to run it. Okay, here we got output as 2 because I is less than equal to. Okay, let's try to submit it. Okay, so okay, since we are starting from I is less than n minus 2, okay, and okay, we can start from I is equal to n minus 1, okay, and write here condition that if I is equal to n minus 1, then we can have like mx sum is equal to max of temp of I comma mx sum, okay, and then we can continue. Okay, temp of I comma mx sum. Let's use this test case. Run it. Yeah, submit. Maybe again got a wrong answer here. So why did we get a wrong answer here? So I was n minus 1. We started from 50. Okay. So we got mx sum as equal to temp of I comma mx sum. Okay. Now, okay. So we need to have this condition here. Okay. So we need to remove from here. I think this will work here fine. Let's run it once. Okay. We need to have that condition. I think if I is equal to n minus 1, let's write this condition there. We need to continue. Let's try to run it again. Let's use this test case too. Test result. Let's run it again. Let's run it again. Okay, let's try to submit it. Okay, yeah, that's accepted. So yeah, this was pretty good question, I think. Not a very pretty good question, but the approach of having this long temp just increases the time complexity. We were having a long sum. So I was trying to reduce the space complexity also. I was trying like, can we try to get it down? But yeah, I think this is the solution which I can get to. So yeah, that's all. Thank you.